Hello, hello. Week before winter break. Woo! All right. So we have our little mini project today before we get started on thermal energy. Good morning or afternoon. Quick announcement. There are no redos on 3.2 corrections. I went over specifically the directions. The directions were written. I went over them verbally or orally, and there was a video in case you weren't sure. And I was present for you to ask clarifying questions. Unfortunately, some of you are in such a rush to get done for some reason that while I was giving instructions, you were just trying to do the corrections and you didn't follow all the directions. Like if things were correct, you were supposed to tell me why they were correct. And some of you just put no corrections, and that was the end of it. Not giving you 10 summative points for you to just write no corrections. That's great that you had a well done experiment, but you have to start telling me why things were correct. And that was part of the instructions for you to do. I'm looking at your thinking and how you are able to synthesize things by just writing not correct, no corrections is not enough, as I explained during instruction. So unfortunately, there are no redos, which I also emphasized multiple times that I am not allowing you to redo it because you were in a rush. Please take this as another opportunity to learn from your mistakes. You'll be fine. Today, it's really important for you to read instructions and listen to the instructions for our ice preserver project, our little mini project for the week. Materials, you're going to need a PowerPoint, the Word document, and you should have all your materials. Now, before we meet again on Thursday and Friday, your ice preserver device should be completely built. If you want to use Wednesday and test it, you are more than welcome to. I do not mind if you work ahead on this. For the pre-lab, so what is thermal energy? We need a little bit of information, a little bit more information on thermal energy. So it helps you with why you're building this little ice preserver. So we know thermal energy is a type of kinetic energy. If you didn't remember that, go back to your flippy on potential and kinetic energy. When we come back in January, that's going to be super important because we're getting into some of the details of kinetic energy in particular. And when we say kinetic, remember kinetic means to move. We can define thermal energy as the average speed of molecular movement or molecular collisions. So anything that's matter except light, because light is not made of matter, when it moves, molecules collide, and therefore you're going to have thermal energy be present. And we measure thermal energy and we call that temperature. So when you check your phone or your computer to see what the temperature is outside, that is giving us the average speed that the air molecules outside are colliding. And then you're going to watch this video from PBS, really informative. We'll probably watch this again in January when we go into some notes on thermal energy. We know that cold, and learning this here, and I know a lot of you know this already because you've told me. So anything that's cold isn't trying to make other matter cold. What's happening is heat energy is always trying to warm everything up. So like when you open your refrigerator door and you feel that blast of cold air come out, you're actually experiencing that because the warmer temperature, the warmer air that is in your kitchen is rushing in. So when somebody's yelling at you to stop letting the cold air out of the refrigerator, technically you're not letting the cold air out, you're letting the warm air in. Please don't correct a family member on that. I did that when I was in high school, when I was taking physics, and my mother was not too happy with my knowledge, if you will. So, how this relates to what we are doing today is you are going to build an ice preserver to prevent an ice cube from melting. You're not adding heat to it. It is just going to simply sit. You might want to do this in your kitchen, have maybe some a towel or paper towels nearby in case you have a leak. But the goal is to make it waterproof. So use your materials accordingly. So our purpose is to build a device that prevents or slows the melting of an ice cube. Have fun with it. There are a few parameters that you do need to follow. You must be able to fit your device in one of your hands. So it should not be huge. It should be no more than 7 inches in length or width. And yes, you're going to have to show me that in your pictures. Must be able to fit 1 ice cube inside. Please do not put more than 1 ice cube inside. Must be watertight for obvious reasons. Must design the chamber so that the ice cube's condition can be quickly and easily inspected. So you need to have a way that if you're going to open it to check how the ice cube's doing, you need to be quick about that. And I would recommend taking a picture of it so you're not leaving your container open for long periods of time and letting all that warm air into your preserver. Must design the chamber so that the ice cube's condition, you may use a maximum of 5 of those heat insulating materials, such as the peanuts or aluminum foil, whatever it is you're using. Tape, glue, rubber bands, if those are on the outside or those are materials that you're using just to kind of hold things together, that doesn't count. But if for some reason you're using tape as an insulator, then that, I don't suggest you use that. But if you are using it as an insulator, then that would count as one of your 5. You may not use additional ice packs, or other cooled or frozen substances. So inside your device, please don't put things like gel packs and frozen peas, etc., etc. Just have the ice cube. We're not looking at you being able to keep the ice cube from melting for 5 days. That would be great, but you don't want that. Use a thermos travel mug as the core. Yeah, so don't use your hydro flask or anything like that. Those are usually bigger than 7 inches. However, please don't use those. You're going to open the Word document and the PowerPoint template. I'm going to show you both of those. And I hope this is showing you this. All right, so this first part I showed you, honor code. It is impossible for me to monitor your melting ice cubes. Some will melt within 30 minutes, while others may last for a couple hours or more. Integrity is extremely important with scientific results. Data is meaningless without facts. So that is why you're taking pictures to go along with your observations, because I need to see that you've actually done what you said you did. As far as presentation, I'll get to that in a minute. And again, these were some of the list of items you could use. It's interesting. People are using, I'm just checking something. Oh, small plastic containers. Yeah, a lot of people are using a small plastic container. I think that's actually a really good idea. So for brainstorming, you're not going to be turning this document in, but you want to jot down ideas, sketch them out prior to, before actually building them, and then you'll take a picture of your prototype and add it to the PowerPoint. Data collection, here's some information, giving your ice preserver a name. You want to use the start time, total amount time, when the ice cube was finally melted, and then you want to figure out how many hours and or minutes. Decide how often you should check your ice cube to observe its melting. Keep in mind, the more often you open your preserver, the more heat will get in. Once every 20 minutes is a good data collecting time. Now, if you start out with 20 minutes and you see that the ice cube's really not melting it, you can totally change it to 30, but you don't want to do 20 minutes, 30 minutes, 15 minutes. You don't want a range of times. Try to stick to a time frame. Now, a student asked me, well, what if I'm in another class? Well, if that's the case, that's what I'm saying. If you want to test this on Wednesday when you don't have to worry about it, that's great. Set a timer so you know how often to check it. If you're going to check it once an hour, I think you would be safe if we were going into other class periods. Once the ice cube is near total meltdown, its status must be verified every 10 minutes. So once you see it's really, really getting towards the end, you're going to want to check it a lot more often. And I would say every 10 minutes. Shaking it's not going to be your best friend. And plus, you're not going to, how do you really take an observation just by shaking it? So you must visually check. We're using the honor system. Honest timekeeping is expected and appreciated. For your data table, make a data table to capture the time and observations. Also, for each time, take a picture to capture the testing stage. This will also, since you're taking a picture quickly, this will help you not let so much heat in, because you, boom, take a picture, close it up. Measurements are always the best, like if you have a scale, but again, then you would be, you would definitely have to do that early on and then measure. But I would say just keep it to the visual, especially something like this. Calculating that might be a little difficult. So I would say take pictures and then have detailed observations. This is a little something for you to do. You'll see this again in January, but you can do this if you want to test your knowledge. I will not be collecting this as of yet. And this is our rubric. So your data recording table, I'm going to give you 4 points total. Your ice chamber design, so your actual device, 4 points. Your actual photos that are here in your data recording table, they're going to get an additional. So your data is worth 8 points. If there's 2 pictures of like the beginning and the end, then I can't really award you full 8 points. I probably can't even award you 6 at that point. The reflection is worth 3 points. And the PowerPoint presentation, which I'll get into, is 5 points. Let me pull that up now. And of course, all the way at the end. So you can use your own PowerPoint. You don't have to use this template. That is completely up to you. Please know that you see these little hash marks, these lines through the numbers. What this does is these are instructions. When you go to slideshow or when you send this to me and you present, none of those slides are visible. Only the slides that don't have the slashes through them are visible. And you are always welcome, if you're in slideshow, you get this format background. You can play with the design, use time, while you're waiting for the ice cube to melt, in between in between measurements, even the first day of class. If you're like, hey, I have my device built, go ahead and figure out what kind of fonts you want to use, colors. But again, muy importante, your font size, your style, and the color has to be readable. If it's not readable, I can't grade it. Let me go back to slide 1. So this PowerPoint template is for your project. So this is all you're turning in. You're not turning in the Word document, just the PowerPoint. And I went over that already. Don't type on the blue slides. Use the white slides. And you can add slides as you go through. Or like I said, use a completely different one if this is a little too confusing for you, or you just kind of would feel better making your own. background theme, again, make sure, it's one thing for a PowerPoint to be pretty. I'm more concerned with it being clean and neat. So really focus and keep it clean, keep it neat, meaning it should be legible. It shouldn't, kind of be all over the place. Don't use fonts that are hard to read. I'm not really assessing you on how pretty your PowerPoint looks. I'm looking at the data. I'm looking at everything kind of follows, and I'm looking at your content. Your content is the most important thing. Now, if you use an image off of Google, it's not an image that you created in any way. Like if you create something in Adobe Spark, great. But if you just want a picture of a melting ice cube for some reason, you have to also copy the URL and put it down here where it says click to add notes. That's where you copy and paste the URLs to. If not, that is plagiarism. So you have to include that. Okay, so for your first slide, the name of your model, whatever it is you named it, your first and last name. Please make sure you're using capital letters. Very important. And yes, you can include images here. For your model design, include a labeled digital drawing or a photo scan of a labeled handwritten with the ruler. So your prototype that you sketch out, you can scan it, you can take a picture of it and include it here. Or what you can do is video it with you explaining, but you need to, when it says to label, you should be giving me the height, the width, the length, and you should also be telling me what kind of materials you used. Students who actually take pictures throughout the construction, even better. For the data table, this comes next. If you need more than one slide to put your data table, great, then do that. Make sure that starting time, meltdown time, and then your overalls are included as well. Remember, photos of the ice. So if you want to include, me personally, for my data table, I would have the observations, if I'm taking it every 30 minutes, that my first 30 minutes, I would have written observations and I would have a picture. I think that's a cleaner way of doing your data table instead of doing, written and then photo. I leave that to you. But that's, to me, that makes more sense, but you do what makes sense to you and just make sure I understand it. And then you're going to do a quick presentation. Tell me about your ice preserver. What did you discover? Did anything interesting happen? Anything that made the light bulb in your head kind of shine brighter? Keep it short. 30 seconds is the minimum, 2 minutes at the maximum. Please don't just, show your device and say, here's my device. The ice melted in 20 minutes. No. Tell me about, like I said, follow some of these. Present your device to me and what you discovered. For the reflection, answer in red text. What was the strength, or what was the strength of your model design? Nothing is not an answer. What was a weakness of your model design? What would you change? So if you were to do this project again, which you may, more info on that later, but what would you change? If you used any references, not the pictures, but any other references, you would put those here, but most likely you're not going to do any research prior to. And then the rubric, there's nothing for you to do here. I will be doing this. You can, if you're in your mind, you want to score it, that's great, but you don't need to do that for me. Okay. And this will be submitted before you leave class on Thursday or Friday. Here is your checklist, and please ask questions today. Have a great day.